Good morning, my dear students. Today we're going to have another virtual class for G6114. This is Math in the Modern World. Today we're going to discuss your week 8, which is all about data management. So these are our objectives. At the end of this module, you are expected to use a variety of statistical tools to process and manage numerical data. 2. Apply the measures of central tendency, dispersion, and relative position in a given certain conditions. 3. Advocate the use of statistical data in making important decisions. So we have now the measures of central tendency. So we have here a data set refers to a collection of numbers or values that relate to a particular subject. For example, the test scores of each student in a particular class is an example of a data set. The number of fish eaten by each dolphin at an aquarium is also considered a data set. So we have here the results of the test scores of students. We have 89, 100, 89, 95, 64, 94, and 92. So also the fish eaten per dolphin, we have 10, 12, 10, 8, 20, 10, 15, and 18. So these are what we call the data sets. No? So data management refers to an administrative process by which the required data is acquired, validated, stored, protected, and processed, and by which its accessibility, reliability, and timeliness is ensured to satisfy the needs of the data users. In this module, data sets and how to use the operations of mean, median, and mode to manipulate the data is the one to be discussed. So I hope you're already familiar with mean, median, and mode. A measure of central tendency is a single value that attempts to describe a set of data by identifying the central position with that set of data. As such, measures of central tendency are sometimes called measures of central location. Kaya tinawag nilang central. Okay? They are also classed as summary statistics. The mean, often called the average, is most likely the measure of central tendency that you are most familiar with, but there are others such as the median and the mode. The mean, median, and mode are all valid measures of central tendency, but under different conditions. Some measures of central tendency become more appropriate to use than others. Mean, it refers to the sum of the numbers divided by n, the same as your average formula. Median, it refers to the middle number if n is an odd or for a rank order list of numbers, or the mean, the two middle numbers if n is even. The last one, we have the mode. It refers to the number that occurs most frequently in a list of numbers or in our data sets. So I've also here the another meaning of measures of central tendency. Measures of central tendency refer to the numerical values which indicate or locate the center of a distribution. Calculations are different for ungrouped data and grouped data. Ungrouped data computations are under descriptive statistics, while grouped data calculations are under inferential statistics. Measures of central tendency basically include the mean, median, and the mode. Other measures of central tendency will also be further discussed. The following are the symbols for the three measures. For the mean, we have your X bar. May grade siya sa taas, no? That's the symbol. Median, X-tel po siya. Ibig sabihin parang may counting S po siya dun sa taas, no? Parang ganun po yung symbol po niya. For the mode, we have X add. So these are now the three measures of our central tendency. Kasi kung minsan, wala na yung word na mean, median, and mode. What you can see are only the symbols. So alam nyo yun, dapat yung pagkakaiba po nila. The mean, median, and the mode. So we have your D, arithmetic mean. When you see arithmetic mean, it is the total of the sum of all values in a collection of numbers divided by the number of numbers in a collection. It is calculated in the following way. Arithmetic mean is equal to x1 plus x2 plus xn all over n. So take note, arithmetic mean is the same as our mean. At the same time, they are the same as our average. Pare-pareho lang po yung formula nila. Gagawin po natin, we're going to sum it up, all the data sets, and then we're going to divide by the number of collections. Kung ilan yung data sets na meron po tayo. So we have your example of arithmetic mean, no? Compute the mean, the first 6 add natural numbers. Solution? The first 6 add natural numbers are 1, 3, 5, 7, 9, and 11. Okay? So, arithmetic mean, gagawin po natin, i-add po natin ito lahat, will give you a total of 36. Then, how many numbers do we have? There are 6 add natural numbers. So, 36 all over 6 is equal to 6. So, therefore, the mean, the arithmetic mean, and the average of these 6 numbers is equal to 6 po. So, we have here another example, mean, no? The mean of a set of values is the sum of all measurements divided by the number of measurements in the set. This is also commonly called as the average. Mean for ungroup data. So your formula, x bar is equal to the summation of x all over n, where your x is the values of the element and your n represents the number of elements. So we have your example. The following are the income of A, Mr. John's business in one of his operating weeks. Find the mean. So this is now our table, no? Of your table 1, income of Mr. John's business for day Monday up to Sunday. Then column 2, we have your D, income. During Monday, income po dyan is 25K. Tuesday, 20. Wednesday, 10. Thursday, 15. Up to Sunday, so we have 4,000. So pag titingnan po natin, habang tumatagal yung araw, bumababa yung income po niya. So we're looking for the average income of Mr. John's business. So from our formula, mean is equal to, we're going to sum up all the numbers. So dito, i-add po natin lahat ng daily income po niya. And then 1, 2, 3, 4, 5, 6, 7. Then we're going to divide by 7 days. So if we add with you your calcu, the total sum is 91,000 divided by 7, which means the average daily income of Mr. John's business is 13,000. Yun po siya, no? So next we have your D, median. This is the middle value of a given set of measurements, provided that the values are arranged in an array. First thing to do is to arrange all items from highest to lowest or lowest to highest. Then determine the number of elements. So median for ungrouped data, this is our formula, x tilde is equal to n plus 1 all over 2, where your n is the value of the element. So the difference between mean and median is that doon sa mean, in-add po natin sila lahat, yung mga data sets po natin, without any making arrangement. Pero sa median, pag meron tayong data sets, the first thing we're going to do para masolve po natin yun is we're going to arrange the data sets mas maganda from lowest to highest. para magamit natin itong formula po na ito to have an accurate answer. Let's say for example, let's use the data from table 1, yung kinamit po natin na kanina. The income of Mr. John's business, which has 7 elements. Let's then arrange the values from lowest to highest. So we have 4,000 up to 25,000. Then we're going to rank them accordingly. We have 1, 2nd, 3rd, 4th, 5th, 6th, and 7. So if we're going to look on that, we have 7 elements. Pag meron tayong 7 elements, using this formula, 7 plus 1 is 8 divided by 2, which means your mean for the ungrouped data refers to the 4th element. So from our table, our 4th element is equal to 10,000. Kaya sabi niya, solution, so we solve for the median. 7 plus 1 divided by 2 is equal to 4. This refers to the 4th element, which is 10,000. So yun po yung median. Kanina, yung mean po natin is 13,000. Ngayon, our median is 10,000. Okay? Next, you have the mode, no? This is the most frequent value in the dataset. It is the simplest measures of central tendency. Ibig sabihin, dun sa sa tatlo, the mean, median, mode, ang pinakamadali is yung mode, no? Mode for ungrouped data. So let's use this problem. The following are the scores of 10 students in a 10-item exam in business statistics. We have 10, 7, 5, 4, 7, 9, 7, 8, 5, 6. Since these scores 7 appear the most frequent, it is considered as the mode. So x hat is equal to 7. So bakit natin sinabing pinakamadali yung mode po dito? Dahil doon sa mean, i-add po natin, then divided by n. Doon sa median, i-arrange natin from lowest to highest. Pero sa mode naman, wala naman tayong gagalawin. Wala tayong isosolve. Ang gagawin lang po natin is to look for the data sets, tapos titingnan po namin kung ano yung set doon na ilang beses lumabas. Dito, in our scores, 3 beses lumabas yung 7. Yung 5, 2 lang po siya, di ba? So which means, yung pinakamarami is 7. Automatic, that is our mode po. Okay? So that's now the difference between the mean, median, and the mode. Also, we're going to go back on our table for Mr. John's business. Pag hanapin din natin yung mode po dito, if we're going to look on our income, 2 beses lumabas yung 10,000. So ito yung most frequent sa kanya. Ibig sabihin, ito po yung mode income po niya, which is also equivalent to 10,000. Okay? So yung mean kanina is 13,000, median is 10, mode is also 10,000. Okay? So next we have the weighted mean. Weighted mean is the formula for the weighted mean of the n numbers. x1, x2, x3 up to xn is weighted mean. The summation of x multiplied by w divided by summation of w, where the summation of x, w is the sum of the products formed by multiplying each number by its assigned weight. And the summation of w is the sum of all the weights. No? So weighted mean is different from arithmetic mean, mean, and average. Iba po yung formula po niya. Example, Alex usually eat lunch 7 times a week, but some weeks only gets 1, 2, or 5 lunches. Alex had lunch only 2 weeks, only 1 lunch for the whole week. On 14 weeks, dalawa. On 8 weeks, we have 5. 32 weeks, we have 7 lunches in each week. What is the mean number of lunches Alex has each week? So dito, gagawin po natin, we're going to collect our data. So we're going to use this formula. sum up of x multiplied by w. So this one is your x, the number of weeks, w is the number of months. So 2 times 1, 2 times 1 plus 14 times 2 plus 8 times 5 plus 32 times 7. Okay? So we have 2 plus 28 plus 14 plus 2, 4. The answer is 294. Okay? Also, add up the weeks, no? We have 2, 14, 8, and 32. The answer is 56. So therefore, if we're going to compute for the weighted mean, we're going to divide 294 by 56. So the answer is 5.25. So ito po yung weighted mean po natin. Pag titignan po natin, it looks like this, no? This is our data. Okay? Then ito yung magiging mean po natin. And also, we're going to have another approach, no? Let's use W for the number of weeks, X for the lunches, then multiply W by X, sum up W, and sum up WX. So we're going to have our table. So the sure weight in terms of weeks, 2, 14, 8, and 32. So the sure number of lunches, we have 1, 2, 5, and 7. So by using the formula, X times W or W multiplied by X, so we have now 2 times 1, 2, 14 by 2, 28, 8 by 5, 40, 32 by 7, we have 224. Then after that, we are going to sum up this one. The total is 294. And also this one, summation of W is equal to 56. So if we're going to solve for the arithmetic mean, 294 divided by 56, the answer is the same as 5.25. So, pareho lang po yung sagot po niya. So, kailan po natin ginagamit yung weighted mean? Commonly, ginagamit po natin yan pagdating sa grades po natin. Let's say, for example, after the first trimester, then if you're going to solve for the GWA, sa mga grades po natin, nakikita po natin doon sa bandang baba, it is not the average. Ang tawag doon is GWA, which stands for General Weighted Average. So, paano po mag-compute mo nun? So, for this first trimester, meron kayong 7 subjects, no? Tapos, bawat subjects po ninyo, may corresponding number of units. So, halimbawa, so G6114, that is 3 units. Tapos, after final, nagkaroon kayo ng grade na 95. So, 3 times 95, yun po yung lalabas dito. That is 285. J6100, another 3 units. Tapos, halimbawa, grade is 100. 3 times 100, we have 300. For P1, halimbawa, ang grades natin doon is, P1 is 2 units lang po siya. So, 2 times 100, halimbawa, grades natin is 100. Your WX is 200. So, yun po yung gagawin po natin hanggang doon sa pang-7 subjects po natin. So, i-add po natin kung ilang units po yun. Tapos, i-add po natin yung total ng units times grades. Ito po siya. Tapos, gagawin po natin, pag na-add po natin yung dalawa na yun, kung ano yung sum nito, i-divide po natin siya dito sa total units. Then, that is now your general weighted average for this first trimester. So, ganun po yung pag-compute ng GWA po natin. Okay? So, you can see the difference between arithmetic mean and weighted mean. So, next we have the median formula when n is odd. Although we have already done this one before, in our previous slide. Median is equal to n plus 1 all over 2. Pag even po naman yung mga data sets po natin, n all over 2 plus n all over 2 plus 1 divided by 2. Okay? So we're going to apply that one. Example, the Jameson family drove 7 states on their summer vacation. Gasoline prices varied from state to state. What is the median gasoline price? Okay? So tulad po ng dati, if you're going to compute for the median, what we're going to do, we are going to arrange our data sets from lowest to highest. Kaya gagawin po natin ngayon, i-arrange po natin dito. Solution, ordering the data from least to greatest, we get, ito na siya. Tapos, i-compute po natin yung median. So, we have 7 states. We have 1, 2, 3, 4, 5, 6, 7. So, we have 7 elements. We're going to follow that one. 7 plus 1 is 8 divided by 2, which means our median will come from the fourth element. And if we're going to look on our data, our fourth element is $1.84. So that is our median. Okay? Kaya sabi niya dito, 7 plus 1 divided by 2, 8 all over 2. So we have the fourth term. So 1, 2, 3, 4. The fourth term is 1.84. Okay? Next, we have your D even data sets. During the first marking period, Nicole's math quiz scores were 90, 92, 93, 88, 95, 97, 87, and 98. What was the median quiz score? Solution, as usual, you're computing for median, you're going to arrange our data sets from less to greatest. If we're going to apply our formula for even data sets, n all over 2, n all over 2 plus 1 divided by 2. And if we're going to count the number of elements, do we have 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 elements or observation divided by 2 plus 8 all over 2 plus 1. 8 all over 2 is 4. 8 all over 2 is 4. So this one is a typographical error. So dapat 1 po ito, no? So if we're going to simplify that one, we have 4. 4 plus 1, we have 5 divided by 2. 9 divided by 2, so we have 4.5 element. Okay? So with that, we're going to count 1, 2, 3, 4, 5. So between 92 and 93. So with that, we have 92 plus 93 divided by 2. 185 divided by 2 is equal to 92.5. That is our median. Or, ang pinakadali po, para makompute po natin, para hindi po natin gagamitin na ito, we're going to look for the two middle numbers. Pag even numbers po yung mga datasets po natin. Itingnan natin yung dalawang nasa gitna na numero, tapos kukunin natin yung average po nila. So that's the way how we're going to compute for the median. Okay? Next, we have the measures of dispersion. We have the range. It refers to the difference between the greatest data value and the least data value in the given set of data values. Example, we have 4, 6, 9, 3, 7. So we have 1, 2, 3, 4, 5 elements. Okay? So what you're going to do, you're going to compute for the range of these data sets. So the lowest value is 3 and the highest is 9. So by using the range formula, range is equal to highest minus lowest. So the answer is 6. So we're going to have that in our figure. This is the lowest, this is the highest, and your range is equal to 6. At the same time, that is our median. Okay? Next, we have your D, standard deviation. It is a measure of the amount of variation or dispersion of a set of values. A low standard deviation indicates that the values tend to be close to the mean of the set, while a high standard deviation indicates that the values are spread out over a wider range. So we have your sigma, Greek symbol, no? Is equal to the square root of the summation xi minus mu squared all over n. So sigma is equal to the population standard deviation. N is the size of the population. Xi is equal to its value from the population. Mu, that is the population mean. So, yung formula po dito is the same as the formula in arithmetic mean. Okay? So, sabi dito, find the standard deviation of 6231. Find the mean, no? 623 plus 1 divided by 4, which means our mu is equal to 3. So, the same formula doon sa arithmetic mean po natin. Next, we have your D variance. It refers to a statistical measurement of the spread between numbers in a dataset. More specifically, variance measure how far each number in the set is from the mean and thus from every other number in the set. So formula, sigma squared is equal to the summation of xi minus mu squared divided by n minus 1, where sigma squared, that is your sample variance, xi, the value of the observation, mu, the mean value of all observations, and the number of observations. Okay? So we have your example. There are 45 students in a class. 5 students were randomly selected from this class and their heights in centimeter were recorded as follows. For the first student, we have 131. Second is 148, 139, 142, and 152. Sabi dito, calculate the sample mean and the sample variance of their heights in terms of centimeter. Next, what is now the difference between, dito no, ito yung solutions po natin. Sample size n is equal to 5. Sample mean is equal to 131 plus 148 plus 139 plus 142 plus 152 divided by 5. So, saan po nakuha yung mga data na yan? Yung n natin, we're referring for the number of population. Dito, the sample population is 5. Although the total population is 45, our sample population is only 5 students. Tapos, so that is our n is equal to 5. Yung sample mean, ang formula po niya is mu, no? Ito muna ang kukunin mo natin, mu. So this is the same formula with our arithmetic mean or average. So gagawin po natin, we're going to sum up this all data, then we're going to divide it by 5. So we have 712 divided by 5. So therefore, the average height of the student or the 5 students is 142.4 centimeter. With that, meron na tayong mu, meron na tayong n. 1 is constant. So, ang susunod natin is how we're going to look for the value ng xi natin. So, yung xi natin, these are the data. Yung 131, 148, 139, 142, and 152. Kaya sabi niya, using the sample variance formula, sample variance equal to 1 all over n minus 1 is equal to the summation of I, which is equal to 1 raised to n, multiplied by xi minus x bar, which represents your mean, raised to 2. So it's equal to 1 all over 5 minus 1. So we have now I is equal to 1 raised to 5 multiplied by xi minus 142.4 raised to 2. So that's our formula. So xi will be equivalent to 131 minus mu raised to 2. Kaya summation siya, no? From 1 to 5 data. Yung height po natin. 148 minus 142.4 raised to 2. 139 minus 142.4 raised to 2 plus 142 minus 142.4 squared plus 152 minus 142.4 squared. Okay? So, kaya tinawag nilang summation. Yung xi po natin, 5, ginamit natin yung formula po niya. And then, n minus 1, we have 5 minus 1. The answer is 4. So, if you're going to look on our data sa numerator, wala po tayong negative. Although 131 minus 140.4, that is negative 11.4. Pero, since we are going to raise that to 2, we're going to multiply it twice. Negative times negative, you're going to have a positive answer. Okay? So with that, if we're going to compute for the sample variance, the answer is 66.3 square centimeter. So yun po yung sample variance po natin. Next, let's know the difference between standard deviation and variance. Variance is the average squared deviations from the mean, while standard deviation is the square root of this number. Both measures reflect variability in the distribution, but their units differ. So, ibig sabihin, kanina, pag ito yung sample variance po natin, the unit is square centimeter. Pag kinuha mo yung square root nito, the square root of 66.3 square centimeter will give you 8 point something centimeter. So yung 8 point something centimeter, that's now the value of our standard deviation. So yun pong pagkakaiba ng standard deviation at saka variance po. Okay? Yan, sabi niya, standard deviation expressed in the same units as the original values, terms of minutes or meters, whereas variance is expressed in much larger units in terms of meter square or square meter or square centimeter. Kaya kanina, yung unit natin dito is in terms of square centimeter. Pag ano po siya, standard deviation, that is 8 point something centimeter. Okay? So next we have your D, percentiles. A percentile is a term used in statistics to express how a score compares to other scores in the same set. A value called X called the P percentile of a data set provided P% of the data values are less than X. Given a set of data and a data value X, we have percentile score of X equal to number of data value less than X divided by total number of data values multiplied by 100%. Okay? So, how are we going to illustrate that one? Ito yung example pa natin. So, example of percentiles. Example, you are the fourth tallest person in a group of 20. So, ikaw yung fourth, ibig sabihin, if you have 20 persons dito, you are in the 17, 18, 19, 20. And you belong to the 80%. Okay? So, 80% of people are shorter than you. Ibig sabihin, magmula 16, 1 to 16, mas maliit po sila. Kaya tinawag nila, your percentile is 80%. Okay? Or 80% taller of these 20 persons. Also, if your height is 1.85 meters, then 1.85 meters is the 80th percentile height in that group. Kaya pag titignan po natin dito, pag ginamit natin yung formula, number of data less than X, so we have 17 divided by 20 times 100. Okay? Check po natin kung tama po yun. Or 16 divided by 20 multiplied by 100. So that is the correct formula. Kaya sabi niya, number of data values less than X. So our percentile is less than 100%. Okay? If we're going to check that, 16 divided by 20 multiplied by 100, then you're going to have 80%. Okay? Next, we have your quartiles and box and whisker plots. The quartiles of the data set are the three numbers Q1, Q2, and Q3. That partition the ranked data into four approximately equal groups. How are we going to have that one? Sabi dito, Q2 is the median of the data. Q1 is the median of the data values less than Q2. And Q3 is the median of the data values greater than Q2. Quartiles are the values that divide a list of numbers into quarters. Okay, quarters, no? That is 25%. So, box and whisker plot. A box and whisker plot is a display used to show the quartile and the maximum and minimum values of a dataset. So, example, no? We have 5, 7, 4, 6, 2, 8. So, again, we're referring for the, may word po dito, median. Kaya paghanap po ng quartile is we are going to arrange our data from least to greatest. Okay? So, pag in-arrange po natin ito, 2, 4, 4, 5, 6, 7, 8. How many elements do we have? 1, 2, 3, 4, 5, 6, 7. Pag ginamit natin only yung formula, n plus 1 divided by 2. So, 7 plus 1 is 8 divided by 2. So, therefore, our median lies on the fourth element. So, 1, 2, 3, 4. Which means this is our fourth element, automatic, this is our median. Or, tawag po natin doon is quartile 2 or middle quartile. Next, paano hanapin yung quartile 1? Sabi niya, quartile 1 is the median of the data values less than Q2. So, ano yung mga data values less than Q2 natin? Ito, 1, 2, 3. Katapos, kukunin natin yung median. O, automatic, dahil 3 sila, ang median po niya yung nasa gitna. That one which will be considered as your Q1. Or, another term, lower quartile. Next, paano naman yung Q3? Is the median of the data values greater than Q2. Kaya dito, ito yung Q2 natin, ito yung data values natin, which is greater than. So, tatlong numero, automatic yung gitna, that is our median. Pero ang tawag po natin doon, that's our Q3 or upper quartile. And the result is, quartile 1 is equal to Q1 is equal to 4. Quartile 2 is your median is equal to 5. And quartile 3 is equal to 7. So, yun po yung tinatawag nating quartile. Next, another example. We have 1, 3, 3, 4, 5, 6, 6, 7, 8, 8. So, the numbers are already arranged in order. So, tulad po ng median, naka-arrange na po siya, wala na tayong problema. We're going to count the element. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, we're going to look for their middle. So, middle number nila is 5 and 6. So, these are the two middle numbers and we're going to get their average. Kaya ang average po niya, 5 plus 6 divided by 2, our median is 5.5. So, this is what we call your Q2 or middle quartile. So, meron tayong Q2. Next, Q1. So, hanapin natin ulit ito, which is data sets less than Q2. 1, 2, 3, 4, 5. So, there are 5 data sets. Automatic yung gitna, 1, 2, 3. Which will represent your Q1 or lower quartile. Okay? Quartile 3, 1, 2, 3, we have 7. That is your Q3 or upper quartile. And the results are Q1 is equal to 3, Q2 is equal to 5.5, that's our median, and Q3 is equal to 7. Next, we have your box and whisker plots. So, meron tayong data sets dito given from 2 to 22. So, we have the lower extreme. This is now the small value in a given data set. For this one, our lower extreme is equal to 2. Upper extreme, the highest value, we have 22. Median value is the middle number in the set. So, ibig sabihin, kukunin natin yung median nitong 2 to 22. Lower quartile, below the value, lower 25% of the data are contained. So, yung median value represents our Q2 kanina. Yung lower quartile represents our Q1. Upper quartile, above that value, the upper 25% of the data are contained. So, the same as your Q3. Whiskers, the line that extend from the boxes, they are used to indicate variability out of the upper and lower quartiles. Okay? So, ito yung whiskers mo natin. Mula dito hanggang dito. Magmula dito hanggang dito. And then, this is our box spot. Okay? So, we have our example. A simple box and a whisker plot. Suppose you have the math test results for a class of 15 students. Here are the results. So, ito yung 15 scores ng math test pa natin. So, tulad po ng dati, we are going to arrange our data from least to greatest. So, ito na siya. Ito na yung data sets mo natin, arranged accordingly. So, the first thing we're going to do is we're going to compute for the median. And if we're going to look on that, there are 15 students. Para makuha po natin yung median po natin, 15 plus 1 is 16 divided by 2, which means our median will be from the 8th element. 1, 2, 3, 4, 5, 6, 7, 8. So this will be our median. Okay? This is an odd set of data. You have 15 data points. It means the middle point is 80. And there are 7 data points above, yun, and 7 data points below. So, tama yung median po natin. Next, step 3, find the middle points of the two values, two halves divided by the median, find the upper and lower quartile. Okay? So, paano natin kukunin yung Q1? Titignan natin yung natira sa datasets mo natin dito. 1, 2, 3, 4, 5, 6, 7. So, the middle will be 70. That is our quartile 1. Lower quartile po siya. For quartile 3, 1, 2, 3, 4, that represents our upper quartile or that is our Q3. Okay? So, tulad yung ginawa natin kanina sa percentile. Step 4, find the extreme values. This is the easiest part. You need to find the largest values and smallest data values. Extreme values are, the lowest value is 54 and the highest values is 95. So we can determine that the 5-number summary for the class of students are 54, which represents your lowest extreme, 70, lower quartile, 80, that's our median, 88, upper quartile, 95 is our highest extreme. So therefore, we are absolutely ready to draw our box and whisker plot. So if we're going to have that one, this is our data from 50 to 95. Our lowest extreme is 54, highest extreme is 95. Median is 80, Q1 is 70, Q2 is 88. So this is the other 25%, this is the other 25%. So which means this one represents the whiskers, okay, from 54 to 70 and also from 89 to 95. This one represents the lower quartile and this one represents the upper quartile and this one from 70 to 88 represents your box. Okay? So, that ends our Module 8, which is all about data management.